Good morning students. Today is we are going to the lecture 4. In this lecture we are going to talk about central tendency and how to measure the dispersions. The lecture objectives, we talk about different types of central tendency, then different types of dispersions. What is measure of central tendency? Measure of central tendency yield information about particular places or locations in a group of numbers. Suppose there are a group of number is there, that group of numbers has to be replaced by a single number. That single number we can call it as central tendency. That is a single number to describe the characteristics of a set of data. Some of the central tendency which we are going to see in this lecture is arithmetic mean, weighted mean, median, percentile. In the dispersions we are going to talk about skewness, kurtosis, range, interquartile range, variance, standard score and coefficient of variation. First we will see the first central tendency, arithmetic mean. Commonly it is called as the mean. It is the average of a group of numbers. It is applicable for interval and ratio data. This point is very important. It is not applicable for nominal and ordinal data. It is affected by each value in the data set, including extreme values. One of the problem of with the mean is that it is affected by the extreme values, computed by summing all values in the data set and dividing the sum by the number of values in the data set. See, here I have used a notation mu. Mu means capital letters. Mu represents mean for the population. The formula is sigma x by n, that is x1 plus x2 plus x3 and so on plus xn divided by n. Here n is the number of elements. For example, the values are 24, 13, 19, 26, 11. Add these numbers and divided by 5 because there are 5 elements. So, 93 divided by 5, 18.6 is the mean of these 5 numbers. So, now the 18.6 can be replaced by this set of 5 numbers. Okay. Suppose in a class, if you say the average mark is 60, so the whole marks of all the students can be represented by a single number, that is 60. 60 will give an idea about the performance of the whole class. Next one is the sample mean. Make sure that the difference here, the x bar, previously for the population mean we have used mu, for the sample mean we are using x bar. X bar is sigma x by n, x1 plus x2 plus x3 divided by n. For example, 6 element is there, 57, 86, 42, 38, 90, 66. So, divided by 6, the mean is 63.167. Now, how to find out the mean of a grouped data? The mean of a grouped data is nothing but weighted average of class midpoints. Class frequencies are the weight. For the formula is mu is sigma f and m divided by sigma of f. Here f represents the frequency, m represents the midpoint. So, sigma fm is nothing but f1 m1 plus f2 m2 plus f3 m3 and so on plus fi mi divided by sum of all f, that is nothing but your n. We will see an example. See, this is the grouped data. What is given? Class interval is given, frequency is given, class midpoint is given and multiplied value of frequency and midpoint also we can find out. For example, see here 20 to 30, there are 6 numbers there, frequency is 6. Suppose if you say the marks of if you say this is an example of a marks obtained by in a class. So, between 20 and 30 there are 6 students there. Between 30 under 40 there are 18 students there. Suppose for this, if the data is in this format, that is in grouped format, how to find out the mean? Okay. First what you have to do? First you have to find out the class midpoint. See 20 to 30, that is the class interval, the midpoint is 25. For 30 and 40, the class midpoint is, that is the middle value 35. Like this 45, 55, 65, 75. Next one, you have to multiply it by frequency and class midpoint. So, 6 into 25 150, 18 into 35 630, 11 into 45 495 and so on. What the formula says, it is a sigma of fm divided by sigma f. Last column, the summed value is 2150 divided by 50. Sigma f is sum of the frequency. So, for this kind of grouped data the mean is 43. Now, we will go to the next central tendency, that is the weighted average. Sometime if you look at the previous values, the each values is given equal weightage. Suppose it is not always the case, there may be some marks there, some values where there may be higher weightage. So, for that case we have to go for weighted average. Sometime you see this, we will list to average numbers, but we want to assign more importance or weight to some of the numbers. The average you need is the weighted average. So, the weighted average is sum of the product of weightage and that value divided by sum of values, where x is the data value and w is the weight assigned to the data value. The sum is taken overall data values. We will see one application of this weighted average. Suppose your midterm test score is 83 and your final exam score is 95. Using weights of 40% for the midterm and 60% for the final exam, compute the weighted average of your scores. If the minimum average for an A grade is 90, will you earn an A grade? So, first we have to find out the weighted average. So, the mark is 83, weightage is 40% for midterm. For end term your mark is 95, weightage is 60%. So, multiply that, then divided by sum of the weight, that is a 0.4 plus 0.6, it is 1. So, 90.2. So, if you are above 90 you will get A, because you are crossing 90 obviously you will get the A grade. Now, we will go to the next central tendency, median. The middle value in ordered array of number is called median. It is applicable for ordinal, interval and ratio data. You see previously the mean is applicable only for interval and ratio data, but the median is applicable for ordinal data. That is a point has to be remembered, and it is not applicable for nominal data. And one advantage of median is it is unaffected by extremely large and extremely small values. Next we will see how to compute median. There are two procedures. First procedure is arrange the observations in an ordered array. If there is an odd number of items, the median is the middle term of the ordered array. If there is an even number of terms, the median is the average of middle two terms. Another procedure is the median's position of an ordered array is given by n plus 1 divided by 2, n is the number of data set. We will see this example. I have taken some numbers that is arranged in order, that is an ascending order 3, 4, 5, 7 up to 22. There are 17 terms in the ordered array. The position of the median is, with respect to previous slide, n plus 1 by 2. So, n plus 1 by 2 17 plus 1 18 divided by 2 9. So, the median is the ninth term here is 15. If see the 22 which is the highest number is replaced by 100, still the median is 15. See, if the 3 is replaced by minus 103, still the median is 15. So, there is the advantage of this median over mean is not disturbed by extreme values. Previously the number of items are odd. Now, let us see the another situation. There are 16 terms in the ordered array, there is an even number. The position of the median is n plus 1 by 2, that is 16 plus 1 by 2 is 8.5. So, we have to look at the term where it is the position of 8.5. That is the median is between 8th and 9th term. Here the 8th term is 14, 9th term is 15. So, average of that one is 14.5. Again, if the 21 is replaced by 100, the median is same 14.5. If the 3 is replaced by minus 88, still the median is 14.5. Now, let us see how to find out the median of a grouped data. What will be grouped data? Here the data is given in the form of a frequency table. In this case, the formula to find out the median of a grouped data is median equal to L plus n by 2 minus CFP divided by F median multiplied by W, where L is the lower limit of the median class. Before using this formula, from the given table you have to find out what is the median class. Then CFP, cumulative frequency of the class preceding the median class, F median, the frequency of the median class, W is the width of the median class, N is the total number of frequencies. See, this is an example. As I told you, before using this formula, first you have to find out the median class. What is the median class is, when you add the frequency, it is a 50. See, 6 plus 18 plus 11 plus 11 plus 3 plus 1, 50. So, divide this 50 by 2, it is 25. In the cumulative frequency column, in the last column, look at where the 25 is lying. It is not between 30 and 40, it is going to lie on between 40 and 50, because 24, the next term is 35. So, the median class for this given grouped data is 40 and 50. So, as usual, L is the lower limit of the median class, that is a 40, plus N is 50, 50 by 2 minus, you see the cumulative frequency of the preceding interval is 24. So, 50 divided by 2 minus 24 divided by the frequency of the median class is 11, W is 10, because the width interval is 10. When you simplify, you will get 40.909. So, this is the way to find out the median of a grouped data. Now, mode. The most frequently occurring value in a data set is mode, applicable to all level of data measurement, nominal, ordinal, interval and ratio. Sometimes there is a possibility the data set may be bimodal. Bimodal means data sets that have two modes, that means two numbers are repeated same number of time. Multimodal, data sets that contain more than two mode. See this one, a sample data set is given. For this data set, the mode is 44, because the 44 is appearing more number of time. How many number of time? 1, 2, 3, 4, 5. Okay. So, the mode is 44, that is there are more 44s than any other values. Let us the formula for finding mode of a grouped data. Here first we have to find out the mode class. For that, look at the frequency column, there 18 is the highest frequency. So, corresponding the class interval is called mode interval. Okay. The mode interval LMO is the lower limit of that mode interval is 30, plus the D1 is difference between 18 and 6, and D2 is difference between 18 and 11. See 30 plus, see D1 is nothing but 18 is the mode interval, and then the previous frequency is 6. So, 18 minus 6 is 12 divided by D1 is 12, plus D2 is the difference between your 18 and 11, that is 7. So, 12 plus 7 multiplied by width is 10. So, 36.31 is the mode of a grouped data. Yes, we have studied mean, median, mode for grouped data and ungrouped data. Now, the question is when to use mean, when to use median, when to use mode. Okay. Many times, even though we study mean, median, mode, we are not exactly told how to use or when to use mean or when to use median or when to use mode. For example, look at this data set. This is left skewed data. This is left skewed data, because the tail is on the left hand side. The example for this is, suppose say the exam is very easy question paper. In x axis is the marks, in y axis is frequency. So, there are more number of students who got higher marks, where the question paper is easy situation. This is an example of left skewed data. So, what will happen here? Here will be mean, here will be median, this will be mode. You see another example where the question paper is very tough. So, this is called right skewed data. Here what is happening, how we are saying that since the question paper is very tough, there are more number of students who got the lesser marks, that is why the skewness on this side. So, here there will be mean, here will be median, this will be mode. Okay. There may be another situation, it is symmetric, it is a bell, looking a bell shaped curve, this situation. Now after looking at this hypothetical problem, now the question arises when to use mean, when to use median mode. Look at the location of the median. The median is always in the middle. Whether the data is left skewed or right skewed, the median is always the middle. So whenever the data is skewed, you should go for median as a central tendency. If your data is following a bell shaped curve, then you can use mean median mode, there is no problem at all. The clue for that choosing the correct central tendency is first you have to plot that curve, you have to plot the data. After plotting the data, you have to get an idea of the skewness of the data set, how it is distributed, whether it is right skewed or left skewed or it is bell shaped curve. If it is skewed data, you go for median as a central tendency. If it is following a bell shaped curve, you go for mean or median or mode as a central tendency. Now we will go to next one is a percentile. You might have seen some of the CAT examination scores, your GATE examination scores, their performance is expressed in terms of percentile, not the percentage, because percentile is having some advantage over percentage, because percentage is absolute term, but the percentile is the relative term. The measure of central tendency that divide a group of data into 100 parts is called percentile. For example, somebody say 90th percentile, my score is 90. So 90th percentile indicates that at most 90% of the data lie below it and at least 10% of the data lie above it. Okay. The median and the 50th percentile have the same value. It is applicable for ordinal, interval and ratio data. It is not applicable for nominal data. Okay. We will see one example how to compute percentile. The first step is organize the data into an ascending ordered array, calculate the pth percentile location. Suppose if I want to know 30th percentile location, for that you have to find out the value I is nothing but p divided by 100 multiplied by n is the number of data set. The I is nothing but the percentile's location, we have to find out the I value. If I is a whole number, the percentage is the average of the values at the I and I plus 1 positions. If I is not a whole number, the percentile is the I plus 1 position in a ordered array. Look at this example, the raw data is given 14, 12, 19 up to 17. I have arranged in the ascending order, the lowest value is 5, the highest value is 28. Suppose I want to know 30th percentile. For knowing the 30th percentile, first I have to find out I, that is the 30 divided by 100 multiplied by 8, so 2.4. The I is nothing but location index, as I explained in the previous slide. I is not a whole number, so you have to add I plus 1, so 2.4 plus 1 is 3.4. In the 3.4, the whole number portion is 3, right. So the 30th percentile is at the third location of an array. When you look at the third location is 13, that means a person who scored 13 marks, his corresponding percentile is 30. So far we talked about the different central tendency, we will go for differing. Now we are going for measuring dispersion. Measures of variability describe the spread or the dispersion of the set of the data. The reliability of measure of central tendency is the dispersion, because many times the central tendency will mislead the people. So the reliability of that central tendency is calculated by or identified by its corresponding dispersion. It is used to compare dispersion of various samples. That is why whenever you plot the data, you not only show the mean, you have to show the central tendency also, because the reliability of mean is explained by dispersion. You look at this data, when you see the first row says no variability in cash flow, mean is same. The second one says variability in cash flow, see there is a lot of variability in the second one, but the mean is same. If you look at only the mean, it will look like same. When you look at only the mean value is same, but when you look at, see the left hand side, the second data set is having more variability. The quality of the mean is explained by its variability, that is nothing but dispersion. There are different measures to measure the variability. One is range, interquartile range, mean absolute deviation, variance, standard deviation, Z scores and coefficient variations. We will see one by one. Suppose there is ungrouped data is there, see this one, you have to find out the range. The range is nothing but the difference between the largest and the smallest value in a set of data. It is very simple to compute. The problem here is it ignores all data points except the two extremes. So, the range is the largest value is 48 in this data set, the smallest value is 35, it is only 13. You see that only the two values are taken care, in between the values is not taken into consideration for finding the range. It is a quick estimate to measure the dispersion of a set of data. Now, we will go for a quartile. Quartile measures the central tendency that divide a group of data into 4 subgroups. We say Q1, Q2, Q3. Q1 is nothing but 25% of the data set is below the first quartile. Q2, 50% of the data set is below the second quartile. Q3, 75% of the data set is below the third quartile. So, we can say Q1 is the 25th percentile, Q2 is the 50th percentile, nothing but the median, that is a very important point. Q2 is nothing but the median, Q3 is the 75th percentile. And another point is the quartile values are not necessarily members of the data set. You see this slide say Q1, Q2, Q3. So, Q1 see first 25% is the data set, Q2 first 50% of the data set, Q3 75% of the data set. Okay. It is nothing but the quartile is used to divide the whole data set into 4 groups, first 25, second 25, third 25 and last 25. Suppose an example for finding the quartile, suppose the data is given 106, 109 and so on. Okay, we have arranged it in the ascending order. First we have to find out the Q1. Q1 as I told you is nothing but 25th percentile. So, the location of the 25th percentile, first you have to find out the location index I, for the 25 divided by 100 into 8, it is a 2. Since the 2 is the even number, as I explained previously, if it is the location index 2, we have to find out that position plus the next position and its average. So, in the second position's data set is 109, the next one is 114 divided by 2, so 111.5. So, the Q1 is nothing but here 111.5. Q2 50th percentile, 50 divided by 100 multiplied by 8, it is a 4, again the 4 is the even number. So, the fourth location is 1, 2, 3, fourth location is 116 and fifth location is 121 divided by 2, 118.5. So, the Q2 or median is 118.5. Then Q3 75 divided by 100 multiplied by 8, again 6, 6 is the even number. The average of 6th and 7th values are 122 plus 125 divided by 2. So, the value is 123.5. This is the way to calculate Q1, Q2, Q3. Now, the next term is interquartile range. So, the dispersions in the data set is measured with the help of interquartile range by using this formula Q3 minus Q1. As we know, Q3 is 75th percentile, Q1 is the 25th percentile. So, range of values between the first and third quartile is called interquartile range. It is a range of middle of. Why we are using quartile range? Because it is less influenced by extreme values, because when we collect the data set, we are not going to consider very low values, at the same time very high values. So, the middle values which is not affected by extremes, that is taken for further calculation. For that purpose we are using interquartile range, that is the Q3 Q minus 1. Now, we will go for deviation from the mean. So, data set is the given 5, 9, 16, 17, 18. To find the deviation from the mean, first find the mean is 13. Suppose there is a graph is there. So, this is a 13. Okay. See the first value 5, the difference is 5 minus 13, that is minus 8. So, this distance is your first deviation. The second data is 9. So, 9 minus 13 is minus 4, this is minus 4. So, this deviation is expressed by these lines. Look at there is a negative deviation, there is a positive deviation. Suppose if you want to add the deviation, generally it will become 0, that is why we should go for mean absolute deviation. You see this, x is given, here there are 2 values are negative deviation, there are 3 values are positive deviation. When you add this, it is becoming 0. So, since we are getting 0, we cannot measure the dispersion. One way is we have to remove this negatives, you take only positive value. When you take positive value is 24. So, 24 divided by 5, there are 5 data sets. So, 4.8 is called mean absolute deviation. It is the average of absolute deviations from the mean. There was a problem in the mean absolute deviation. I will tell you what is the problem there. See next we will see population variance. It is the average of the squared deviation from the arithmetic mean. Okay. So, the x is there, mean is there. So, when you add the absolute deviation, it is 0. One way in the previously in the mean absolute deviation we have taken only positive value, now we are going to square it. The squaring of the deviation having some advantage. One advantage is we can remove the negative sign. Second one is when the deviation is less, when you square it, for example minus 4 square is 16, see minus 8 square is 64. So, what is happening, more the deviation, more the squared value. Okay. So, here the sigma square is sigma of x minus mu divided by x minus mu whole square divided by n. So, 130 divided by 5. Here we are squaring. The purpose why we are squaring? For there are 2 reasons. One is to remove the negative sign. The second reason is giving for higher penalty for higher deviation values. The next one is the population standard deviation, because already there is a variance, but variance is a squared number that we cannot compare. Suppose the 2 numbers are given, say 12 and 13. That is easy, intuitively we can say which is higher, which is smaller. Suppose 124, 169 is given, it is a squared number, we cannot compare intuitively. And not only that, it is in the squared term, we want to have it in the actual term. So, for comparison purpose, for that purpose we are taking square root of that. So, 5.1 is the standard deviation. Next we will go to the sample variance. The formula is same, but only thing is it is divided by n minus 1. Why we are dividing by n minus 1? The reason is that to make the variance as the unbiased estimator. This is due to degrees of freedom. Since we know the value of the mean, we have lost 1 degrees of freedom. That is why we are dividing by n minus 1. So, it is very important whenever you find the sample variance. So, in the denominator there should be a n minus 1. So, here the variance is 2,21,218. This is another sample standard deviation, just you take the square root of that, it is a 470.41. So, square root of the variance is nothing but standard deviation. Now, the purpose is why we have to study this standard deviation, because the standard deviation is giving an indicator of financial risk. Higher the standard deviation is more risk, lesser the standard deviation is lesser risk. In quality control context, generally when we manufacture something, suppose you have plant A and plant B or shift A and shift B, whenever the variance is lesser, then the quality of the product is high. The process capability also, we should have the lesser variance means the process capability is high. The next was for comparing the populations, household income of 2 cities, employee absenteeism in 2 plants. For this purpose is for comparing the population. That means wherever there is a lesser standard deviation, so that is having higher homogeneous data set. You see, look at this one, mu and sigma. See, this is a financial security A and B. See, the return is 15-15. it's both are giving equal return, but look at this, the sigma standard deviation, because in financial context it is measured as the risk. So, the first one is 3%, second is 7%. So, the security B having a higher risk. So, always we will go for where there is a lesser standard deviation, because mean is same, we are at the same time the risk also should be same. So far we have seen different central tendencies, different dispersions. In the coming class we will use Python, we will take some sample data set. I will explain you how to find out central tendency and the dispersion of the given data set. Thank you very much.